Being from Huntington, we were a little apprehensive coming to Fairfield because we get blamed for burning down the town in 1779. It wasn't us. It wasn't us. It was the Loyalist refugees from New Jersey. They just happened to live in Huntington at the time. We're glad. So here we are. The Lefferts Tide Mill, there it is in Huntington. Huntington is made up of two peninsulas, and then it goes inland, of course. And we're pretty much right across the water from Norwalk and Stamford, so not too far from here. This is an aerial view of our mill. There's the mill pond on top. The little red building is our mill building, and the tide gate is in the middle of the dam. So there were many, many mills built in Huntington throughout the years, starting in 1657. Most of them were stream-fed. We had 4 tidal mills and 1 windmill, which is very interesting, but we're not going to talk about that. This is the map that shows where all these different mills were. And the blue stars are stream-powered. The red circles are the tide mills. And the green star is the windmill. So you can see there throughout the town on the different necks, and we usually start on the east. And this is a tide mill we know nothing about. It's on Eaton's Neck. If we go up, it's that neck all the way up there. Eaton's Neck was owned by the Gardner family from the 1790s. And at some point, William Gardner apparently built a tide mill. And the only reason we know is because this photograph exists that says Dam and Raceway at Old Tidal Mill. We've never seen a building. We don't know how big it was. The pond is not that big, so we don't think it was a very big mill at all. And it was probably just for people who lived on Eaton's Neck, we assume. And we didn't even include this in our presentation initially until I was giving it to a group, and somebody said, "What about that mill pond on Eaton's Neck?" And then that drove us to the local historical society to find this photograph, and we realized there was at some point a tide mill there. The first tide mill is the next one we're going to talk about. This is the second tide mill, is in Centerport, and it's the mill up on the top there. And Mill Dam Road still exists, and the mill building itself is long gone, but that was built in 1774. There had been an earlier grist mill a century earlier, but that was fed by the streams and ponds at the head of the harbor. So this is the Centerport Mill Dam Dam, and you can see it has that board walkway elevated over the dam because at high tide it apparently flooded quite regularly. So that was the only way to get access, was to walk across that little boardwalk, very rudimentary boardwalk. So this is the Huntington Tide Mill, which was the first one built in town, 1752. It was the third one in Huntington Harbor. The first two were at the head of the harbor. The one I mentioned in 1657, further south, and those were powered by a stream that ran into the harbor. But in 1752, Zophar Platt had permission to dam off the head of the harbor and built his mill there on the west shore of Huntington Harbor. And this is a close-up photograph of it, and it had a fairly large wheel, and it had that nice screen to protect people from being splashed by the water as the wheel turned. This is a watercolor done by an unknown artist, just we know his initials, RNW, and it shows the mill, and then the owner of the mill, his house up the hill, overlooking his domain. He also had a lumber yard and coal yard. That was the Wood family. And you see the ships coming right up to the dock to pick up the flour. So what we want to talk about is the Lefferts Mill, which still stands. The Huntington Mill was torn down in 1930. I'm not sure the date of the Centerport Mill, but that was also
early 20th century.
Early 20th century it was demolished.
And Vanderbilt used some of the timbers, I think, from that mill too.
Yeah. William K. Vanderbilt had an estate in Centerport nearby, used some of those timbers supposedly. And the Huntington Mill, some of those timbers were apparently used in a mansion somewhere in Connecticut. But the Lefferts mill is here at the end of what we know as Puppy's Cove. And this is, as we said, the last mill standing in town, and it was subject of a historic American engineering record survey in 1975. And Alan Comp said nice things about it, that it was a remarkable survivor, the only one of its kind, still in so many of its original features, and which we are trying our best to maintain and restore under challenging circumstances because of rising sea levels. So here's just a few pictures on the inside. The permission to build the dam was given by the town of Huntington to Coles Wortman in 1793. He had married Abraham Van Wyck's daughter, but he seems not to have pursued the building of the dam or the mill to too great an extent, because by 1794 he sold it to his father-in-law and his cousin, who was also his brother-in-law, because first cousins married. Another daughter of Abraham Van Wyck Sr. married Coles Wortman, and another one married her cousin Abraham Van Wyck Jr. So they're called senior and junior, even though they're uncle and nephew, but they're father-in-law and son-in-law. It gets kind of confusing. But in any event, even though he's an older-looking gentleman, that's junior. He's the younger Van Wyck. But they did have the mill long enough to stamp their name on the horses, the two horses, because there's a pair of millstones in this mill. Now, the interesting thing is we don't know exactly what the connection is, but the Van Wyck family and the Gerritsen family, who had a tied mill in Brooklyn, were related. One of the Van Wyck cousins married a Gerritsen, not until 1798, so we don't know if that was why the Van Wycks got interested in milling, but there's a connection there, and when the families were first introduced to each other is unknown. But at least there's a connection, and we thought that was interesting because I think this was a focus of a Tide Mill Institute meeting a few years ago. This is where Toby usually talks about this, but this is the family tree that I talked about, where you see all the cousins in that third line, Gerritsen, and then the one who married her cousin, Van Wyck, and the daughter who married, where's the daughter who married Coles Wortman?
We don't have him.
We don't have her. She's an important player, but she's not there.
Well, again, remember that the second daughter, the Wortman married, died in 1795, and that's why Coles Wortman got out of the picture.
Right. Coles Wortman moved back to Oyster Bay because his wife had died.
But this is the Gerritsen.
So that's the Gerritsen mill in Brooklyn. So this is a picture of, from about 1890, of the dam and mill looking from the east. You get very confused with east, west, and north and south at our mill. But this is from the west, looking east towards Huntington Harbor. And here again is that artist, RNW, painting this mill. So he was on a little mill painting expedition. And again, you see the foundation of the mill right on the water, which is no longer visible, and we'll get into that a little bit later. And there's the tide gate and people fishing nearby, and there's the water wheel, which no longer exists. This is probably the last picture, well, not the last picture, it's an early picture with the water wheel still intact. And we realized that we could figure out the dimensions of the water wheel because we know where the axle was, where it went into the building to turn the gears, and it went to the edge of the building, and we just measured that, and it's about 16 feet in diameter. Now, the mill survived for many years with all its gears intact because it was not, unlike some of these other mills we've talked about, modified into a restaurant or some other use. It was purchased after it went out of business in about 1870s when it stopped being used. The last miller died in 1882, and when the land was purchased by a wealthy banker who had a summer residence nearby. So it stayed in that family for 3 or 4 generations, and they used it as sort of a swimming cabana. They had this floating dock off of it. They used it for storage inside, but they never threw anything out. They just left what was there, all the gears, where they lay. They've been moved around a bit, and we're still trying to put them back where they belong, but everything is still there except the wheel. And here's a picture before a lot of the renovation was done, and it was painted red, which it no longer is, and everyone keeps asking us, paint it red again. We're not sure if we're going to do that or not, but there's no wheel, as you can see. We give regular tours, as Claudia said, about 10 or 12 a year, and one of the highlights is going out to see the force of the water that comes through that tide gate. This is the water coming in on the incoming tide, and this is one of the remnants of the tide gates, which we no longer have, but Kurt, who's our local engineer, is making plans to rebuild the tide gate in some fashion, just as a demonstration, not to use it to hold back the water, but just to show how it would work. And I want to turn it over to Toby now, because he is really going to help us explain what makes, we think, this not unique just because it's completely intact, because it is a great example of the beginning of industrialization. We, of course, are celebrating the 250th anniversary of the revolution this year, and there's a series of programs in the town of Huntington. And if you want to be included on the 250th anniversary calendar, you have to have a relation to the revolution. And we decided the Van Wyck Mill, even though it was built after the revolution, is important because it's the road to industrial independence. And Toby's going to explain how this really deserves credit, not the mill itself, but the system that it used as the beginnings of the Industrial Revolution in this country. So you want a microphone?
I have one.
You have one. Excellent.
Okay. It works. Yeah, our boss, Claudia, insisted that we get the name Independence in it, and so the Industrial Revolution. And so the Industrial Revolution was our way to get on the 250th anniversary schedule. I'm starting on a slide. I guess the Garretson Mill relationship, we're not sure of exactly how much that influenced it. But as he explained, in 1793, Coles Wardman, the son-in-law of the owner of the farm, the elder, we call him the elder, Abraham Van Wyck, got permission from the town, and this is well documented, in 1793 to dam off the end of the cove to create a mill pond and to build a mill. And the town was very grateful to that. His wife, however, died in 2 years later, and somehow he went back to Oyster Bay where he had come from and sold his rights to the two Abraham Van Wykes, father-in-law, nephew, son-in-law, all that relationship. That eventually ended up, the son-in-law, Abraham the Younger, bought the entire farm in 1794, and the father or the uncle took over, kept his half of the rights, so they shared the rights until it was sold entirely to the younger Abraham Van Wyck in 1798. When actually this mill was constructed, it was somewhere between 93 and 98, and we use the date 94 at times 95. It may have actually been later. And this gentleman, and knowing more about this gentleman, Oliver Evans, who had received a patent, one of the first patents ever issued, a United States patent. There were 3 of them issued in 1790, granted by George Washington and issued by Secretary of State Thomas Jefferson. And the first patent was for manufacturing potash and pearl ash, and that wasn't very industrial. The second one in August was for a new method of manufacturing candles, but the third one in December was issued to Oliver Evans for his revolutionary flour and milling machinery. And it was to his revolutionary automatic grist mill system for manufacturing flour and meal. This system used a continuous mechanical process, including devices like the hopper boy to move grain through every stage of milling with significantly less labor and improved output quality compared to traditional methods. This invention was pivotal in the development of automated manufacturing in America. Now, this I have to, nope, other way. So what was the start of the Industrial Revolution? Well, when I was taking social studies in 8th grade, the name that was always mentioned as the father of the Industrial Revolution was Samuel Slater, who was an Englishman, of course, who came over memorizing the workings or the design of a woolen mill, and built in 1793 the Slater Woolen Mill in Pawtucket, Rhode Island, which of course is a museum now, still stands. Eli Whitney was also a name mentioned as inventing the cotton gin in 1793, but he received the 72nd U.S. patent. So the Lefferts Mill, which was built, and we say here 1794, but now we're thinking it's somewhere in between. It may be closer to when in 1798, the younger Abraham Van Wyck sold 50% of the rights of the mill to the Lefferts brother, and hence the name of the Lefferts Tide Mill. I mean, it's been called the Van Wyck Lefferts Tide Mill for years. The organization that owns it now decided we wanted to shorten the name somewhat, so we now just call it the Lefferts Mill and Preserve. But this, in 17, George Washington was so impressed with the design. He had a grist mill in his Mount Vernon farm that was stream fed, but he was so impressed with the design that he purchased a license to upgrade his grist mill. There were other Evans mills near the Washington estate, so he sent his millwright to inspect it, and then two of Evans' brothers came to Mount Vernon to oversee the installation of the new mill. And that was 1791, so it predates the Slater Mill and the Eli Whitney invention by a couple of years anyway. And so we're, as the more we learn about Oliver Evans, the more impressed we are. Evans, in the paperwork that applying for his patent, described the automatic flour mill as follows. These 5 machines perform every necessary movement of grain and meal from one part of the mill to the other, from one machine to another, through all the various operations from the time of the grain is emptied into the wagoner's bag until completely manufactured into flour without the aid of manual labor, excepting to set the different machines in motion. This is his explanation and his design and his diagram of the different machines that were in his application. It's interesting that Oliver Evans goes on and invents a good number of other things, including the first actually powered vehicle, other than horse-powered vehicle. He applied for a patent for that, and it was a land and water vehicle that would do some dredging. And he applied for a patent in 1904. He didn't get that patent, but it was a vehicle that would be powered by a steam engine rather than anything else and on wheels. And he wrote this book in 1813, and it was about the prophecy of 1813. It was about the coming of the railroad, how he was going to take the steam engines that were propelling boats through the water now and put them onto carriages, put the carriages on rails, and create transportation that would be much more efficient than water transportation and faster, much faster. But he wrote this really because he believed in justice in the matter of his own patent rights. He had written books. He had written his book to set forth this grievance. This is the 1813 book. But in either 92 or 95, he also published the Young Wheelwright and Miller's Guide, which had his patent, all his patent diagrams in it. And so where Washington is said to have purchased a license, once he publishes that book, anyone could have picked up that book and put his mill operation, inserted into their mill. And we think that that corresponded to when the Lefferts mill was actually built. And the Hare diagrams that in the Hare report doesn't really mention Oliver Evans and give credit to it, except for one of his machines, which was an elevator shaft that moved the grain around. But these are basically what the traditional mill would look like. You'd have your mill, you'd have a pit wheel attached on the inside, you'd have the wallower, and then what they call here stone nuts that would drive the two sets of grinding stones. That would be traditional in any kind of mill. But the interesting thing was this third pinion, or lantern pinion here, that went up the 3 stories of the building and would create all the auxiliary movement in the mill. And there's where you could transfer this little gear, and we'll see a picture of it that's in the Lefferts mill, would transfer the vertical shaft into another kind of pit wheel type thing attached to a pulley instrument. And you'll see that the pulley, the line of pulley that you see in many machine shops, exists in this mill, and that produced all the motion that moves the grain through the system. Okay, so this again comes from the 1975 Hare report. It shows the existence of some of those pulleys I talked about, but it doesn't really show the wheel, of course, is no longer attached, is no longer there, but it goes into this room here, and this is where all those gears are that are going to produce the power to operate all the different machinery. This is a diagram from the Oliver Evans design, and it shows a little bit different. There's going to be interpretation depending on who builds it. Here is the ground floor, and the wagoner comes in, dumps his produce here. It gets elevated up to the 3rd floor, or in this case, the 4th, well, it's the 3rd floor, and where it gets cleaned. And all of these operations are still in some way maintained in the Lefferts mill, as we'll see in some photographs. And then from here, it would drop down. Now, the one thing that Oliver Evans did not include was a smudder, which came in the middle of the century, of the 19th century, which was put into the Lefferts mill, and we'll see photographs of that. But basically, once the mill got clean, it got dropped down into a garner that would drop the grain into a hopper that would sit on a horse, and then dropped in, get ground by the stones, would drop down further, and in our case, it's the 1st floor because we don't have a basement, it's full of water. But once the flow comes out, it would get elevated back up to the attic, or the 3rd floor, where it would have to be dried. And that was done by what he invented as the hopper boy. And you can see, and we have these gears laying around. We haven't been able to place them in place. That's one of our goals that we've placed some of them, but we haven't placed all of them. We haven't figured out how it all worked. But this would dry the flour, because it would come out from the stones very moist, and drop into, once it got dried, it got dropped into a bolter. Again, all the power that would spin the bolter, that would sift the different grades of flour, would be provided by the water wheel and come from that auxiliary axle. And then it would drop down into the 1st floor, where it would go into barrels and then shipped out to where it would go. And I've kind of created this flow chart that would operate. This is what a little bit different. This is the Lefferts mill, actually. The grain comes in from the farmer on the ground floor. It gets hoisted up, and we'll see the gears that hoist them, again, powered by the water power. Up to the third floor, it would get cleaned, like it did in that previous diagram, drop down to the second floor, get elevated up to the third floor, where now it would go into a smutter, where you get smut was something that could be banged off before it got ground, before the wheat beans got ground. Then it would drop down into the garner, into the hopper, and into the grindstones. Then it would drop down to the first floor through the chutes and into a horizontal trough that would move the flour or the meal horizontally by an Archimedes screw, which we have the remnant of from the mill, from the Lefferts mill. Then, after it was in that, it needed to be dried, so it would go drive up again to the third floor, where the arrangement of the hopper boy would be dropped into the bolter, and then from the bolter dropped down into the barrels, and then off to market.
Could you explain the function of the hopper boy?
The hopper boy, we don't have a picture of it, I don't think, here, because we haven't figured out how it goes. I guess we could go back to that diagram from the patent, but basically it laid the flour, the wet flour that had come up from the grinding. It came from the first floor back up to the third floor, and it would rake it so it would dry it out so it became more, so it could be sifted into the different grades of flour that in the bolter. It was a dryer, right. And that task was always handled, it's called a hopper boy because usually in the manual flour mill, grist mill, someone would be up on that third floor raking it manually. And this was a mechanical device. Again, one of the machines that he had invented. Now, these are the pictures of the gears. These are the two pinion gears. This is the wallower in here. Again, this would be changed. This would go up. This would be a stone gear. So right up above here, in the bottom here, it would go through the bed stone. I mean, you guys know how that works anyway. I mean, every grist mill works the same way. So this is not necessarily different from any other traditional. This is the hoist up on the third floor. It's amazing. We found we've discovered two different clutch mechanisms so that the spinning of the belts could be taken off or disconnected to stop the operation, or connected with this kind of a clutch mechanism that's here. And this was significant. And of course, this would hoist the flour. This door is to the outside in the back of the mill. And this would hoist the flour up to the third floor. It would be brought in the building, taken over to the cleanser, the screening, and I think we have pictures of that. This is that vertical auxiliary power. This is the smutter. This is the elevator that brought it up from the first floor up to the third floor. This belt would be connected to that, which would turn that, which would operate not only the elevator, but also this wheel, which would create the speed of the smutter, because the smutter would want to go much faster. So it's a smaller wheel from the larger wheel. This is where the power to operate the hoist would also come from. And of course, these are all familiar. It would be in a traditional thing. This is a crane that still exists. These are pictures that the Hare visit took. So that's what the black and whites you can see are from the Hare visit in 1975. This is the garner. This is off. This is, there's the two wheels are here. This is just set off of that second wheel. And that's the crane that could be used to lift the upper wheel, upper stone off it, spin it, so that it could be redressed.
You want to point out the pulleys?
Oh, yes. And then this is part of the system, a picture that shows the numerous pulleys that are going to operate the different, one of these pulleys is going to be underneath that cleansing basket that was cleaning them up on the third floor. And the holes in the floor, again, tell us, how the power got to each one of these things, each one of these machines. This is similar to the previous picture, a little closer up. And this is that auxiliary shaft here that would come up, spin this, turn that, and that would start your belts. And it would go to some of those other pulleys, and that's how the whole thing got mechanized. This is, again, that's the garner. That auxiliary shaft is over here, would line up with these pulleys, and that would spin the number of things. We found another clutch that would move a belt from a fixed pulley, I guess, a fixed wheel onto a spinning wheel, so that would undo the motion. Again, another example of a clutch. And of course, one of the things that is mentioned in the Hare report is the elevator. And these are the two different grades of elevators, but this bucket is made of wood and leather. The elevators must have been refurbished, and they became with tin buckets. And they're attached to rawhide belts. And one of the belts goes, one of the existing belts goes from the first floor all the way up to the third floor. And then, of course, after it gets ground, it's got to be taken back up to the third floor. These are some of the gears. We're not sure where they go, except this one we know, and we've actually placed that. I hope there's a photograph that shows you, but that's the Archimedes screw that we'll see that moved the flour after it got ground horizontally over to an elevator that brought it back up to the third floor to be dried. These are somewhat of a mystery. They're on the second floor, but we're not sure, and these are covering openings that either allowed the grain to go from one floor to the other by gravity, or allowed belts to come through the floor and create the power drive. But we think these are where the bolter was. And it's either a table or it held chutes that went from we're on the second floor down to the first floor after the flour had been milled and dried and sorted. Now, this is an early picture of the mill. At this point, they had, this was the first of an effort to hold the foundation in place. They put cement around it. That didn't work out very well, and it had to be replaced in the 1980s with the first bulkhead, and we've since had to replace that bulkhead with a second bulkhead, and we'll see pictures of that. But that's the dam with some repairs on it. And this is this is 84, I think, or 80. This is the 94, or when was Pataki governor?
94.
94. So this is the 94 grant where we put the, which was a major reconstruction, right? And we'll see, hopefully if the video works, we'll see the results. We'll see some of that. This again is some of the restoration that we've done. When the group, you really didn't explain the ownership of it. After the estate that owned it for 3 generations. They owned it from when they bought it in the 1880s until it was given to the Nature Conservancy 3 generations later in 1968, and they owned it for 50 years. but they didn't really take great care of it. And when the current organization, which were basically homeowners living around the pond, they didn't want the Nature Conservancy really did not want to spend money on keeping the dam updated or in good repair and the mill itself in good repair. So they were looking to give it away, really, and they finally found a group of homeowners that were willing to form a nonprofit organization. But by the time we got it, these were almost falling into the water. You can see this is the basement area, which is at high tide full of water. So when we had our restoration done most recently, we had these beams put in and to make sure that they were supported back up and straightened back up. And when the framers, as they explained maybe in the video, once they got it straightened up, they were able to turn these gears by hand on these blocks. Okay, this is that Archimedes screw that we had found up in there, and even though the trough is missing, because we really don't see it, but these are right under, this is on the first floor, and right above it is where the flour would come out from the two grinding stones and drop into a trough, and this would again be powered by water power, would move the produce horizontally over to an elevator that's over here, and then it would go back up to the third floor to be dried. Okay, so not only did we have to repair the dam, the mill itself, but the dam needs constant repair. And with the rising tide of things, we've got a lot more repairs to do as the years go on. But this would be the sluice here, and this would have been the sluice gate, and the original vertical posts are here. And the idea is to let the water in, as any tide mill does. The gates would close, and then they'd flow out by opening these. Now these were just opened by some kind of capstone? I think that's what's called. Yeah. Would help lift the gate up a few inches, because with every tide mill, it's an undershot wheel, and there would be counterclockwise rotation to it, as we saw, and therefore the need of that splash guard. But after we got it, that what you saw was filled in, the sluice that was filled in, that actually had eroded out. And so at high tide, we would get, this would fill up with water. We had to build a temporary bridge across it, and we knew we had to do something with that, because what it was doing was affecting the foundation of the mill.
How high is that sluice?
About 6 feet. It's not 6 feet here. I think it's 6 feet on the other side coming in from the mill pond, and then it narrows somewhat. But we could see this is where the center axle was that Robert pointed out. So it gave us, that picture gave us the width, the diameter of the wheel. We did get that repaired by replacing the sluice gates here and blocking off that with what is that, Brazilian hardwood that wouldn't rot out. But again, you get a better indication of this here. This had been a repair or cement work that had been done in the 1980s.
Why is it bluestone?
Why
are there bluestones there?
Oh, bluestones, to look like water, of course. We didn't know what to do to cover that, and we decided to use bluestones, where we used, as you'll see in the video that we're going to look at next. There is very few buildings or structures like this in the country that remain. There are mills that are reproductions, and they're interesting to see. But this one in particular, when you come, you just feel the age of it. You feel the necessity that it provided for the town of Huntington, milling corn and wheat into flour. In 1793, the Van Wycks got permission to build a dam across the inlet here, and so we had a mill pond created, and then the Lefferts brothers joined the operation, and that's why it's the Van Wyck-Lefferts Mill. It was built under a design that was the third patent offered in the United States, given by George Washington, the President, and signed off on by Thomas Jefferson, the Secretary of the State.
This building represents a period in time that there almost is no other documentation of. You can go anywhere in the country and see water mills, grist mills, sawmills. There are 10 locations where tide mills exist in this country, and this is one of them, and the other one's not nearly as complete.
First thing I did was build a little bridge outside a couple years ago, and I came in and saw the building and thought, wow, what a spectacular example of a timber frame. Not just the frame itself, which is the architecturally magnificent, but the mill and all the pre-industrial era machinery. And it was a factory also that was operated for 80, 90 years, pre-coal, pre-fossil industry, relying on nothing but lunar gravity off of the tide.
The whole building is a 3.5-story machine. It's just a beautiful piece of history that really deserves to be saved and passed on to the future generations.
It was owned privately until 1968, and then the Nature Conservancy took it over and maintained it, and the Huntington Historical Society opened it up to the public by running tours for years. But the Nature Conservancy, they were trying to give it to a more appropriate organization to restore a structure. And so a group of neighbors really decided they would form an organization, and the first thing they wanted to do was to make sure that the dam held. Then we were going to do a few repairs on the building itself.
Where the mill was situated, the paddle wheel had the pass-through for the water to go back and forth. And obviously the wheel is no longer in existence, and the water was coming through and out of that channel there. And as it was coming in and out, it was undermining the foundation for the mill dam. We filled it in with a green heart lumber, and then we put the riprap stone 3.5 to 4 inches, so that way it's a living, breathing breach in the dam where the water will come in and out, but it will not have the velocity to undermine the foundation of the mill dam. The challenge is, as the water comes in, it washes away some of the grout and the jointing of the dam wall. It's underwater 50% of the time, so we can only access it at a low tide to pin the rocks together and to put the mortar joints in there. It had to be a special mortar that would dry, that would not get washed away as the tide came in and out. This entire wall, 110 feet behind me, was basically collapsed and in rubbles. Part of it was on the shoreline, and so we had to scavenge the ground to get the stones and rebuild the wall over here. The engineering is dealing with water and the tidal force. It's very strong, very consistent, and then you have wave and wind that beats on it. So as the men were putting the wall together, it was almost like a puzzle piece where the rocks, they had to be placed at certain angles for a nice tight fit, and then we would reinforce it with what they call a heliflex pin. So we would drill through the rocks and put a metal rod in that would basically connect and tie the rocks. And then after that, we would put the mortar inside the joints on top of that. So it's almost like artwork. I think we have almost 200 tons plus of rocks in this dam here that we had to transport down. You know, the guys got into a groove and they got it done.
The whole concept of a tide mill is that the gates want the incoming tide to flow in, and then when the tide is going out, it closes the gates, and so traps the water in there, and then you open up at another point where the water can flow out over the wheel of the mill.
This is a book that was written by Oliver Evans in 1795. It's called The Young Millwright and Miller's Guide. He invented mechanical systems to replace people inside the mill, moving the grain and the flour through the process of milling. And it's an early physics, hydraulics, mechanics of engineering book. And I've been doing some of the math. The wheel, we estimate, turned at about 10 to 16 revolutions per minute. It was a 16-foot diameter. The stones are about 5 foot in diameter, and we calculate that they turned about 105 RPMs each. There's 2 stones, and that it could do about 5 to 6 bushels an hour of grain.
Imagine the thing all put together with belts slapping and wheels turning and shafts being greased and grain running through. I went to see the grist mill at Mount Vernon, which is complete, and they operate it every half an hour, and they're grinding grain with it. It's utterly amazing machine. It's mystifying to watch. This mill is bigger than that.
We had to jack the entire building up, came in and rebuilt the foundation.
We immediately started to take off all the brick nogging and loosen up the sides. We went through piece by piece to figure out exactly what was going to be saved and what wasn't.
There were a number of restorations done over the last 40 years or so. In the early 80s, they redid some of the foundation, the sills were replaced, and in the mid-90s, this whole north wall got a makeover. But their project stopped at a certain point, and there were other members of the frame that were failing, that were probably either left alone at that time for budgetary reasons or logistical reasons. So we came and addressed basically the rest of them, the things in the frame that needed more repair.
I've been building and restoring traditional boats and buildings for 30 years or more. We restore things, which means you have to understand how it was put together, then you have to carefully take it apart in such a way you're not causing damage. Then you have to put it back together, which makes it so much more complex.
Everything that they took apart to repair, they had to provide support for, hold things up so that it wouldn't collapse, and then cut out the bad parts and reconstruct new parts and fit it all back together again. And that was quite a challenge. A lot more damage was found than what we had originally anticipated.
It's a long tradition, obviously, timber framing, going back 1,000 years easily. A scarf joint is basically anytime you join 2 pieces of wood to one, you can cut them on an angle like this and put them together and fasten them somehow, and that's a simple scarf. There are other ways to make them stronger and more complicated to take different kinds of loads. And it's still the strongest joint aside from using modern glues for joining 2 timbers together. A project like this motivates me in that I can preserve a building that's historically relevant, put all these different pieces of wood together in different ways and working each of them into each other to create the fabric that is this structure. You're dancing with the architecture in that sense, kind of making all these pieces of wood withstand all the forces that the frame might endure.
Good. Sam, watch your back.
Wait, up! Okay. Yeah, swing over.
I would say that the biggest issue was when they took the roof off the building and to see the damage in the roof joists. We thought 6 of them were damaged out of 24, and there was actually 18 of them that were severely damaged and rotted and no longer structurally capable of supporting the roof. And so we ended up having to replace it to make it as historically accurate as could be.
about 16 months, $300,000. The dam now is in solid shape, and so is the building structure itself. Future plans are to restore the water wheel on the outside and to work a little bit more on the old gears to get them set up to show how they had historically been used. So please remember to help support it. There's still a lot of work to be done, and it's a real national treasure that sits here in the middle of the town of Huntington.
Personally, I feel privileged to be involved in this. The work is always interesting and it's always rewarding, but it's also really hard. You're constantly problem solving.
Do you specialize in this type of work? Is it something you have to improvise kind of along the way?
Oh, well, improvisation is definitely the word.
I love when I come here in the morning. It's beautiful. It's paradise. It's like if I died and you told me this was heaven, it was probably here in that regard.
I just got a tremendous interest in it, and partly because of my family's history. My family came to Long Island in 1640, came out to Huntington in 1795, and settled a lot of this area.
I've always been interested in historic structures. The first thing I do when I walk into an old building is I start looking around. I'm looking up, I'm looking all around. I'm a structural engineer. It just interests me.
Oh, every day I wake up excited to move the building one step further to being strong, being stable, being beautiful, and being open to the public so that people can come and enjoy it.
This is, as the video would have said, that we had the dam restored, and we had a whole bunch of pictures. You could see how it had gouged out. This is what it looks like today. In the last project we had done was to rebuild the bulkhead, and so this is the way it looks today with the new bulkhead. But you can see, the effect of about 6 to 8 feet of tide that created your waterfall. Here's where your wheel would have been. Here's the sluice. Would it come over? There's the water flowing out from the pond. Right now, the gates, we have them permanently set about halfway up. So there's constant water in and out of the pond. And at the same point, the organization who lives in these houses that surround the pond don't have a low tide ever. There's always water in the mill pond. And that was something that they were very interested in. Most of the people on the board and in the organization live around the pond. Robert and I do not, but we were asked for our relationship with the Huntington Historical Society that provides tours to these and have for years. This is the most recent look at the dam. As you can see from that aerial view, both sides of the dam are privately owned. So the only public access to it is by water, and that's by the town allows the launch, and the Historical Society takes about 15 to 16 people out on tours during the summer. But this is one of the things that is happening and is a constant problem. The tide overflows this at very high tides, and we noticed this sinkhole really right here in the middle. It's just actually, you don't see it in the long picture, but it's right in the middle of that, and that's got to be repaired and addressed.
The fines that weren't able to.
What's that?
The fines, the very fine material, it washed away.
Yes, it does, and so that hasn't worked. These you basically remain stable, and we have in the video it shows the whole process of rebuilding the dam. Not only, historically they're built with timbers framing in the middle that get filled in with dirt and so forth. This was a better, more substantial dam than the one in Centerport that Robert showed with the walk bridge over it. But it's still a problem. We had, well, it's just going to be a constant problem. So this is a picture of it from the dock, or we don't go from that dock, but we go from a dock on the other side, the town launch, out to this building here, off in the distance. And again, the head of the parks, national parks, was quoted, "Today none survive with the historical integrity found in the Van White Lefferts mill. The mill is a remnant of a past long vanished from Long Island, our only access to the actual craftsmanship and technology." And he said pre-industrial America. Actually, I think this is can be attributed to be industrial America. If you Google who is the father of the Industrial Revolution, you'll get Samuel Slater. I think you should have gotten Oliver Evans. And this is the launch, or one of the launches that goes out to it. Of course, we only can go at high tide, and so hopefully at some point, whether you visit us and have 2 years from now, have a meeting down in Huntington, and we can take you out too and show us, and hopefully by then we'll have things in more figured out. This is a view of the pond when it's very tight. You know what? Let me just go through these because we took these slides out. This is the other side of the mill pond, which again is a private home now, and luckily she's on the board, as is Dr. Finkel on the other side. This shows you how low the tide gets at low tide. Now, this is part of the scouring out that we had repaired. This, I think, is, yep, they're the workmen on repairing that particular part of the dam. This is the washout of that dam that was now been repaired. You can see how the dam broke apart there, and they had to rebuild that part of it. And that's a restored dam at one point. That's the 1984 bulkhead that was put on that we just had to replace.
You should mention, Kurt Dietrich was a young engineer just out of school in 1984. And one of his first projects was this mill dam. And he designed that bulkhead. And then 40 years later, it finally gave out, but he was still involved. So he designed the replacement as well.
Okay, I guess that's it.
Was there clay used at all in your dam?
It seems more like sand. I don't think there's much.
Riprap
and sand.
When it scours out, you can see the wood cribbing. I mean, much like what you found sunken in and they fill that, and then they put the stone on each side of it to make it a wider. But the real dam, I think, is in the middle of that. And the little sinkhole that's come up, we're afraid that water has worked its way through underneath and obviously created a cavity, and that's what's sunk. So we have more repair to do on the outside of it.
We spent a lot of money repairing that dam, as you saw in 2021. We fixed it after all these years, but it's never fixed because we get the sinkhole, we get washouts in different locations on the face of the dam as well. And we actually brought a dam expert from Haley Aldrich up in Boston to come look at it. And he suggested running steel sheeting down through the middle of the dam to be the actual dam, and the historic dam will be just sort of for aesthetics. It won't really be functioning, it'll be the sheeting, but that's $1 million project.
And that's also a problem because you have to leave the tide gates open, and you don't want it to sneak around the steel.
The steel, right.
The steel should, so you have to tee it off somehow. Right.
Yeah, we really haven't done an analysis of soil boring to really see what's down there, but what we see is mostly riprap and sand and gravel. But that's also years of repairs and topping and all of that. Another thing we're considering is injecting some kind of epoxy into all the voids in the dam. But We don't know how many voids there are, we don't know where they are, and that will be also another difficult solution.
Thank you very much.
All right, thank you.
Thanks for having us.